Fossil fuel age is ending. Known deposits will have been gone by 2052. The demand for energy is increasing. Reusable energy requires rare earth elements. The world is at its hottest for at least 12,000 years. To survive, people have to transit from a linear to a circular economy. In a circular economy, waste becomes the next resource. Therefore, the system requires much more energy in order to recycle or upcycle all the materials. Consume less, consume better creates systemic change. Nevertheless, all the aforementioned transitions to a cleaner form of energy and a circular economy are essential for our further life on this planet. So where to get green energy? Electricity is both a fundamental part of nature and one of the most used forms of energy. It is possible to state that energy is everywhere. Plants, food, bacteria, mushrooms, biowaste. In order to elicit this energy, we use organic waste, microorganisms, and plants to build batteries, solar cells, and wires. Most of the bioelectronics can be fully compostable. Swampy soil is extremely bustling environment, full of geobacter, microorganisms, and decay processes. We've tried to capture its electric potential using wetland soil as an electrolyte. The bioplastic became the cathode, while the photosynthesizing mass and geobacter worked as the anode. Maybe one day, whole wetlands can be turned into environmentally neutral power stations. In cities, on the other hand, mass batteries could work as electricity-generating house elevations. This solution could also purify the air and work as water retention systems. Other biotic batteries can be created using fermented foods as kombucha or pickles. The fermented beetroot juice, cucumbers, or cabbage are full of probiotic bacteria, which can be used to create the electricity current. The idea behind these food batteries is to create energy from 100% organic ingredients, which later, after use, can be composed. Our sun is one of the most important sources of renewable energy. Therefore, we started to work on compostable DCCs, dye-synthesized solar cell. Photovoltaic cells that are created from food scraps, as well as raw materials, available in most of the kitchens. The vegetables and fruit juices were used as the dyes in this photoelectrochemical system. The system is based on the potential difference generated between the dye's reaction to sunlight while being in contact with a semiconductor. The textiles waste can become a great part of the bioelectronics world. We can use them as wires or elements of the batteries by dipping them in the all-nature mixtures that textiles can work as electrolytes between the anodes and cathodes made from metallics, waste, kombucha or carbon. Those kinds of batteries give extremely promising results in energy production, as well as are extremely interesting paths to consider in order to minimize wastes generated by fashion industries. This circularity and regenerative design is crucial for us in developing the bioelectronics. Most of our batteries and photovoltaic cells can be fully composted. After it is composted in anaerobic conditions, the biogas is produced, as well as the fertilizer, which can be used to grow rich in dyes, vegetables, and fruits. As a result, these circular and regenerative energy generation processes are possible. In a future full of technology, electricity is going to be one of the most important goods. Therefore, it is important to make it more inclusive and available. The bioelectronic elements can be built from local materials and thus may create more decentralized and environmentally friendly forms of generating the electricity.